Hey, what's up guys? Mr. Fabella here with a continuation of what we were doing earlier. So the last lesson that we did was to find the surface area of rectangular and triangular prisms, and basically any prism you have, right? Today we're going to move on and do the surface area of pyramids, both regular and not regular pyramids, and we'll talk about what that is later, as well as the surface area and maybe even throw in some volume of composite shapes. So we've done composite area before. Now we're going to do composite shapes. So like, let's say a rectangular pyramid on top of a rectangular prism. What is the volume of that? What is the surface area of that? All right, so let's get started with some vocabulary here. First we have the lateral surface area. So I'll put a different official definition down over here or up there. But basically the lateral surface area is what is the surface area of a three-dimensional object, excluding the bases, the top and bottom. Or in this case, if it's a pyramid, what is the surface area of the three-dimensional shape, excluding the base. So slant height, I'll kind of throw in a picture here and then a definition here as well. But slant height is going to be, if you have a pyramid, different from the height. So the height is from the base to the tip of the pyramid. That's the height of the three-dimensional object. Slant height is what is the height of the triangle, because a pyramid is made up of triangles. What is the height of the triangle from the base? So it's called a slant height because if it's pyramid, it's slanted, right? So it's this part. So what is that height? So it goes along the face of the object. And then finally, regular pyramid. So some people throw around the word regular around. That's an actual word for geometric shapes. We've talked about this before. Regular means the same on all sides. So a regular rectangle is a square. So a regular pyramid, that means if it's a four-sided base of a pyramid, that means it's a square pyramid, because regular means all four sides are equal. All right, let's move on to some of this now. Here in the book, it gives you the definition of lateral area. The lateral surface area, LA, is the perimeter, is half the perimeter of the base times the slant height. And we're going to use that for a square pyramid. So for the lateral area, that's not including the base. As you can see here, lateral area equals 1/2 times the perimeter times the L. That's not the length. L actually is the slant height. Okay, so that is only for regular pyramids. If you don't have a regular pyramid, you would have to find all the separate sides separately. But for this case, most of the examples here are going to be regular pyramids. Okay, so let's look at our first example here. Find the total surface area of the pyramid, round to the nearest tenth. This looks like a regular pyramid because the base is 4 and 4. Okay, so we can use the formula we learned before. So total surface area, so surface area is going to equal the lateral area plus the base area. So I'm going to write this out first. So lateral area is 1/2 times the perimeter times the slant height plus the base area. Okay, so let's just work through this. 1/2 times the perimeter. Perimeter of this square base, that's 4 by 4 by 4 by 4. That's going to be 16. So 16. And the slant height is given as 9 inches. So as you can see, that's what I was talking about. It's the height of one of the triangles of the pyramid. So that's going to be 9 plus the base area. So this is the base once again. So base of that is 4 squared, which is 16. And then from there you just work it out. This is 8 times 9 plus 16, 72 plus 16. That's going to be 88. It's going to be 88, and then this is area, so square inches. Okay, another example here, very similar to the one that we just did. So find the total surface area, round to the nearest tenth. Okay, so surface area is going to be the lateral area, which I'll just write here as 1/2 the perimeter times the slant height plus the base area. Okay, so 1/2 the perimeter. I'm going to draw out this square. All right, so I drew out that square. This is a 3 by 3 square. And so if it's a perimeter, there's 3 there and 3 there. That's going to be 12. And then times the slant height, that's going to be 7. So 7 there, plus the base area. 3 times 3 is 9 square inches. So that's going to be plus 9. So again, just follow order of operations. This is going to be 6 times 7 plus 9, 42 plus 9, 51. This is in inches squared. Okay, so this is a little different. This is a triangular pyramid, but it's still a regular pyramid, even though it doesn't look like it. So 10, 10, and 10, it's still a regular pyramid. So we can still work with this. So surface area is going to be the lateral area, which is 1/2 the perimeter of the base times the slant height plus the base area. So 1/2 the perimeter of the base. So this is 10, 10, and 10. And then over here, right there, whoops, that shows 8.7. Okay, first the perimeter of this rectangular, or this triangular pyramid. 10, 10, and 10, that's 30, times the slant height. So the slant height is not 8.7. That's this bottom part here. The slant height is from the base, what is the height of the triangle of the lateral sides. So that's shown as 12. Okay, that's shown as 12. So my slant height is going to be 12. Now plus the base area. So the base area, it's not like a perfect, like all the faces of this triangular pyramid are not exactly the same. So if you can see this one, the base is going to be a little shorter, and then this is tall. It's still a regular pyramid though. So if I'm looking at the base area, that's what I'm looking at right here. So the base area is a triangle, so it's 1/2 base times height. So the base is perpendicular to the height. So that's 10 times 8.7. Okay, so move this over a little bit. All right, so that's a lot of things to look at. I'll put some parentheses around here. So this part is a lateral area, and this is the base area. And then now you just follow order of operations and work through it. So this is, so this is going to be 223.5 square feet. Didn't say it around, so we're just going to leave it like that. Okay. All right, so a word problem here. Sal is wrapping gift boxes that are square pyramids for party favors. They have a slant height of 3 inches and base edges of 2.5 inches long. How many square inches of cardstock are used to make one gift box? So basically it's asking how much surface area, total surface area is there. And this might be kind of hard if you're just reading this. You really should draw it out. Okay, so usually you would start with a parallelogram at the bottom if you're going to draw something three-dimensional, and put a okay, so I did the best I can to draw a square pyramid. I kind of put the dot, or the apex in the wrong place, but that's okay. So we're just going to follow what it says here. Slant height of 3 inches. So I'm going to use a different color here of red and put the slant height to show that's kind of following down here and then right there. And that's going to be 3 inches. And then it says base edges of 2.5 inches long. So 2.5 here, 2.5 there. Since we've been doing this before, off to the side, I will draw a square and remind ourselves that this is what the base looks like. Okay, so now let's start working here. So our surface area, okay, so 1/2, the perimeter of this square, 2.5, it's a square times 4, is going to be 10. Okay, the slant height is given as 3 inches, okay, and then plus the base area. The base area here is 2.5 times 2.5 because it's a square, so that's 6.25, I think. Okay, and then we'll just work through this. This is going to be 15 plus 6.25, so 21.25, or 21 1/4 square inches. All right, that's how many square inches are used to make one gift box. Okay, so we've done surface area of pyramids. Now let's move on to something more intense a little bit, is the surface area of composite figures. As you can see here, you have a three-dimensional shape that is two, it looks like two rectangular prisms put together, basically. Okay, so this is a little harder. The volume of this would actually be a lot easier than the surface area, because volume, you just find rectangular prism on the bottom plus the rectangular prism on top. That's fine. This one, you have to split it up into different surfaces, and it's, for some people, it might be a little hard. I wish we were in the classroom where you guys could actually like put some Legos together and see, but for this, we're just gonna have to kind of visualize it. So there are actually, let me see, 1, 2, 3. Yeah, there's actually 3 different kinds of shapes here. So if it's hard to see, see if you can see the 3 different shapes, 3 different areas that you're gonna have to find. This part right here, this is probably the most obvious part. This purple part is corresponding with that right there, the sides. So there's 2 of those, okay? So this is going to be times 2, yeah? This part right here, that's actually the top. And you can see 16 is over here, 16 by 6, that's the 6 over here, because if this is 6, this is also 6. And then, conveniently enough, there's a bunch of these smaller rectangles here. So maybe the first one is obvious as this one, right? But actually, this one is also going to be the same, right there, okay? Because if this is 6 here, this is also 6 inches. And if this whole thing is 16 inches, right? And this is 8 inches, that means this little part here is going to also be 8 inches. So let's see. Well, first of all, okay, we said this is times 2. This is times 1, this bigger rectangle. Now let's count how many we have here. Let me do this in pink. So we have this one, 2, and the bottom, like right there, that's another one. And then on the bottom of here, that's your last one. So this is gonna be times 4, okay? So kind of hard to visualize sometimes, but 1, 2, 3, 4 of those smaller rectangles. Okay. And I think I said that there was one of these. I was mistaken, I forgot. There's actually 2 of those. This is times 2 because I forgot this back piece right here. That's kind of tricky also because the top and the back piece you cannot see at all. Same with this bottom piece and the bottom piece. It's very easy to miss. Okay, so now that we have our plan, it's just a matter of multiplying things out. Okay, so this is actually a composite figure. We've already done this before. So we're going to need this rectangle, 16 times 8, plus this other square, 8 times 8. 16 times 8 is here, 8 times 8 is over there, okay? And we said that there is 2 of these because the face is facing us, and then the back face. So this is going to be all times 2. All right, I'm just gonna leave that. I'm gonna write out all of the equations first and then do the calculations with a calculator later on. So we can do it all at once. Okay, now this is probably the most straightforward one. This is a 6 by 16 rectangle, and there are 2 of them. And then here we have a 6 by 8 rectangle, and we said there are 4 of them. All right, so now let's just kind of chug away at these calculations. Okay, so this is going to be 192 times 2, which is 384. This is going to be 2 times 96, and that's going to be 192. Okay, and this is going to be 4 times 48, and that's also going to be 192. For total surface area, I'm just going to have to add those all up together. So that's 768, and this is square inches because we're talking about surface area. Okay, so let's do one last one here. Here we have a cube, rectangular prism or a square prism, that's a cube, with a square pyramid right on top. So now we're taking all the stuff we've learned before, but there's also something you have to be careful of. Okay, so for the surface area of this figure, let's see, we're gonna try to break it down into the shapes again. Okay, so let's see. For sure you see a square there, right? How many of these squares are you supposed to count? Now, if you said 6, because you're like, oh yeah, a die has 6 sides, a cube has 6 sides, then think about what surface area means. Surface area is the outside part. So this face right here, this face that you see, that's actually not on the outside, so you're not supposed to count that. So also that goes for the base of the pyramid. The base of the pyramid is not going to be counted. We're only going to be counting the lateral area of the pyramid. All right, so now that we know that, let's break this down to this. So we have these, right? And now let's see what we're going to do. So we made 2 different polygons, right? And we are not going to use that top face of this cube. So this is going to be times 5. And we have these triangles, and there are 4 of them. So this is going to be times 4. Okay? And this, breaking it down like this, is much easier. So you don't even have to find the area of the pyramid. I mean, you could if you wanted to find the lateral area, which would be 1/2 perimeter times length. But you'll actually see that's where 1/2 perimeter times length actually comes from when we do this. So I'll mention that a little bit later. So let's go through this. Area of the 5 squares is going to be 8 times 8. And there are 5 squares on the surface. So it's going to be times 5. So 64 times 5. So that's going to be 320 square feet. Okay, now we have our triangles. Okay, so a triangle is 1/2 base times height. So the base there is 8 times the height, which is 6.4. Okay, let's put those in parentheses so it's not confusing. And then times 4. Okay, so here's the interesting thing. Let me rewrite this actually. I'm going to erase this. Let me rewrite this. This is the area of one triangle, right? So this is going to be times 4. Okay, so here we have it. Now we're going to work through all this. So this is going to be 102.4 square feet. Okay, and let's, just for fun, let's see if this actually works as well. So lateral area is going to be 1/2 the perimeter of that. So 8 plus 8 plus 8 plus 8 is going to be 32 times the slant height, which is 6.4. If you see that, that actually totally makes sense, because 8 is right here and there are 4 of them. See that? So that's the perimeter, because it's a regular pyramid. And then the 1/2 is just the 1/2 over there. So you end up getting the exact same answer, 102.4. That's kind of cool. To find the total area, you just take the 102.4 plus 320, and then that gives you 422. That gives you 422.4. And this is in feet, so square feet. All right, so this was surface area of pyramids and the surface area of composite figures. I hope that was helpful, and I'll see you guys next time.